Hello there, this is Alan. Welcome to today's presentation. The title of the presentation is Transcriptomic Biomarkers of Biological Aging Among Healthy Individuals Reflect the General Health Status. So this is an original research. So there were two goals for the study. The first goal was to actually build an aging clock from mRNA alone. The second goal was to measure biological age of unhealthy individuals using a clock trained with healthy individuals. So what we wanted to do was to use the mRNA clock or the aging clock as a measure for unhealthy or healthy. So this is a schematic of the study. So for the training, we've used only healthy people, 324 of them. And for testing, so to test the performance of the clock, we've used two independent healthy cohorts, and to actually see if it works on the unhealthy people, we've used the cardiomyocytes, cardiovascular disease, sorry, heart disease, mental disease, and infected patients for our study. And on the figure on the left, we see the performance of our clock. So in the training data set, we achieved 0.91 prediction accuracy, which is a correlation between the real age, the real calendar age of the people, and on the y-axis is the predicted age, which was predicted using mRNA expression. For the testing, we can also see it is well performing with 0.9 Pearson correlation R. And MAE, the mean absolute error was around 6, which means that by around 6 E's, that has a prediction error. And the most important features out of 47 were, for example, CD248, NAP1L2, and TM8010, and O2-7A. The red over here shows that the gene expression of the feature actually has a negative correlation, and gene expression over here on the blue is having a positive correlation. And when we actually enrich these genes, 47 of it, we see in the CAG pathway that these are actually involved in melanoma, P53, glioma, cardiomyopathy, and etc. So the age predictive genes that we've built in the mRNA clock is actually associated with cancer and CVD, which are chronic diseases. And so to actually measure the unhealthy aging in the disease individuals, what we've actually built or devised was this measure or an unhealthy aging index, which is just basically a prediction error or an absolute difference between the prediction line and the actual dot point. And this is in the field of aging, it is called a transcriptomic age acceleration. So the prediction error is a healthy aging index, and how much the transcriptomic age has accelerated is what we think as being unhealthy. So over here, we've in the x-axis is the different groups that we tested, and the y-axis is the index we devised. And we see, in general, there are no real difference between the groups. This is a mean, the total and the grand mean, except for the infected patients. So our conclusion over here in our study is that infected patients have most healthy deviant or unhealthy mRNA profile. So we think that the infected patients at that moment are really accelerated instantaneously. So this is a finding that shows that the infection is not only the result or the outcome of aging. What I mean is susceptibility or the fatality, but rather the aging is actually caused by infection as well. Yeah, that was it. Thank you.